A 7 1/4 inch gauge Sweet William steam locomotive, part 8, scraping off the old paint from the cab area, then testing and repairing the twin axle driven water pumps before refitting the boiler, which makes the job much easier. This episode opens with a clip from the previous episode showing the heat resistant paint drying in the outer part of the workshop on the smoke box and chimney assembly. And in the inner part of the workshop, on the bench, I'm scraping off the old paint from the running boards. This paint wasn't very well keyed to these pieces of metal, and it was very simple to remove it. I just scraped it with my special chisel with the blunt end. In no time at all, the paint was fast disappearing. In this clip, I'm just working around the edge of the reverser. The green paint on the tanks and the cab and the boiler wrapper is okay, really. But before I even started work on this engine, in this area the paintwork was very poor. Before anybody writes in, yes, I am aware that paint chippings are going all over the engine, but don't worry about it. I'll be cleaning the engine fully in due course. In a very strange sort of way, this is fairly therapeutic. But watching the process is not very therapeutic, so I'm going to speed the video up. There's another benefit of using this chisel with the flattened end. It also removes any burrs from the holes. There is a high volume of paint particles coming off this part now, and I certainly do not want to trigger disorders in certain viewers, so I'm using a vacuum cleaner now to pick up the particles. Why didn't I use the vacuum cleaner in the first place? Well, I just like to live life on the edge. I'm nearly at the end of the job now. Most of the paint's gone, and there are some scratches on the steel, which really doesn't matter because before I paint this piece of steel, I'm going to be sanding it all over with very coarse sandpaper. Scotch-Brite is great for cleaning metal, but it's not quite coarse enough for this job. It was also difficult to get into the corners where there are some fixings. For that job, I used my Proxxon motor tool fitted with a wire brush. Note to self, when using a Proxxon motor tool fitted with a wire brush, do not wear a fleecy jacket, because the bristles that are ejected by centrifugal force from the wire brush stick into my fleecy jacket and then annoy me for the rest of the day, as some of them go through the jacket and stick into me. That's another job out of the way. The next job is to look at the twin axle pumps between the frames. Here are the two eccentrics that drive the twin rams on the pump. As I reassemble the locomotive, I think I will fit some sort of piping system which will supply oil to the eccentrics. Before I do that though, I am going to remove the caps from the tops of the oilers, because these are no good at all. Time now to test the pump to see if it works. I'm going to connect a piece of silicone rubber tubing to the water inlet to the pump, and a similar piece of silicone rubber tubing from the pump's outlet. Both the inlet and outlet tubes will come from and return to this plastic bottle of water that sits very conveniently between the frames. With an air line connected to just one side of the engine, it's time to give it a run and see what happens. The pump seems to be working very well. When I decide which tube is which, I remove one of them, and now I can show the water outlet from the pump being fed back to the water supply. The output is not very smooth, but then again the engine isn't running very smoothly. The water flow, of course, is very dependent on the speed of the pump. The good news is it's pumping a lot of water, more than adequate to feed this size of boiler. Looking at the pump between the frames, the problem is one side is leaking quite badly. The design of this pump is really good for servicing. Once I remove the single split pin, I can pull the main drive pin out, followed by the ram. I think I've found out why it was leaking. Someone has wound a lot of cotton around the groove, possibly in an attempt to hold the O-ring in place because the groove is fractionally too wide. This really doesn't matter, and you certainly don't need to wind cotton around it. I think what's happened here is when the pump's been working, this original O-ring that I've stretched out to show the flat on it has been pressed too hard against the wall of the pump cylinder, due to the cotton thread packing forcing it out of the groove. I completely removed the packing. Here I'm lubricating the groove and I'm fitting a normal O-ring. And yes, the groove is a little bit too big, but it doesn't matter. Now the ram is no longer leaking, and besides, if this O-ring wears out, it's a very quick job to fit a new one, as you've just seen. Here's a close-up of the water pumping operation, and it's a bit erratic because the engine's going too slow. This will cause incorrect ball lift on the pump, and the balls will probably rattle and bounce. Talking about rattling balls, here I'm shaking a rattle can, that's what the noise is. It's a rattle can filled with self-etch primer, which I'm spraying inside the frames where I'm going to refit the brackets. No masking required at this stage. I just point the can accurately at the area I need to paint. And any paint on the two side panels is going to be removed by the sanding operation. That's it for this episode. I think that the boiler is going to be coming back next week. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.